and that's a bond angle of 180 degrees. So you can tell us about borane. Borane is AX3.
And what is the geometry? And the angle? 120. Feel free to yell out very loudly. We want people in open courseware to hear the answers coming from the room.
All right, so the next case we're going to look at is CH4, or methane. And let's do a clicker question here to make sure everyone is remembering these geometries. And this should be very quick, and try to not turn the page back one and tell us in 10 seconds here what the geometry is. %. That is a new record. Very good. Tetrahedral.
All right, while I'm holding the carbon dioxide in one hand and methane in the other hand, I just want to do an additional plug for the energy debate tonight. So there will be representatives from both presidential campaigns that are going to be there to answer questions. And I'm not sure of the exact format. I'm not sure whether all audience members are going to be able to ask questions or not. I'm not sure if I'm going to be there. I'm supposed to be giving a talk, actually, ironically, about energy at the same time. But if I can't make it and you're allowed to ask questions, I'd like you to ask a question for me. So my lab looks at enzymes that remove carbon monoxide and carbon dioxide from the environment. And I have an energy initiative grant to do this because MIT recognizes that an important part of any energy initiative is thinking about lowering pollutants and greenhouse gases. So I heard on Thursday at the debate when Governor Sarah Palin was asked directly if she really doesn't think there's any connection between global warming and any man-made activities, that she said, well, you know, it could be just regular energy or temperature fluctuations, and she doesn't want to point any fingers. So she's not quite sure. I also learned on Thursday that she will head the energy initiative in a McCain-Palin White House. So if you go to this debate, I would like you to ask, what is your plan for sequestering carbon dioxide and other greenhouse gases? You can ask both candidates, and please let me know what the answer is, because I think that's a really important question. Here we have carbon dioxide, here we have methane. We need to be thinking about greenhouse gases.
You can also throw in the question that you do know this is tetrahedral and 109.5 degrees. Show your chemistry knowledge here. All right, and let's keep showing that we know our geometries. Let's look at PCl5.
And what is the geometry here? Yep. And the angles? 120 and 90.
So 120 equatorial and 90 axial. And last we have SF6.
So what is the geometry here? Octahedral and angle? 90.
All right, so there's our set of examples, one for each for those shapes or geometries that have no lone pairs. And now let's think a little bit about once we do have molecules with lone pairs. And the biggest point to keep in mind when we're comparing lone pair electrons with bonding electrons or electrons in bonds is that when you have electrons in bonds, they have less spatial distribution than lone pairs. So that's just a way of saying that electrons in bonds, they take up less space.